This question is related to the Pascal principle. So, figure 3.1 shows a hydraulic lift in a car repair workshop. This is a hydraulic lift. The car supports are there on which the car is placed and the car is being lifted up. The hydraulic fluid transmit the pressure caused, caused by piston A equally to each of the four pistons. Hold up the car support. The pressure throughout the fluid is same. They already give you a hint that the pressure will not change. The pressure is same. A force of 100 Newton is applied on piston A. That is just enough to raise the car. Use the value from figure 3.1. Find the pressure caused by piston A on the fluid. So how much pressure is applied by piston A on the fluid? A force of 1000 Newton and area is 0.01 meter square. So what is the pressure applied on A? Pressure is force divided by area. So 1000 divided by 0.01. So 1000 divided by 0.01. The answer will be 100,000 Pascal. So that's a pressure which is applied by the fluid at piston A. So it apply a pressure of 100,000 Pascal, or in short I can say 1 exponent 5 Pascal. So if piston A causes a pressure of 100,000 Pascal, how much pressure on each piston? According to Pascal principle, equal amount of pressure applied. So here the pressure will be 100,000 Pascal, 100,000 Pascal, 100,000 Pascal, and 100,000 Pascal. Not divided by 4, it will be equal. That's a Pascal principle, that what pressure we applied on the fluid, the same amount of pressure applied equally in all the direction. So the pressure will not, each piston will experience 100,000 Pascal. That's a Pascal principle, that what pressure we applied on the fluid, the same pressure is applied equally in all the directions. So we apply a force of 1000 Newton. So when we apply a force of 1000 Newton or area of 0.01 meter square, so how much pressure we applied? We applied a pressure of 100,000 Pascal. So if we apply 100,000 Pascal, same amount of pressure is applied equally in all the directions. So the first answer is 100,000 Pascal because the force is 1000 and area is 0.01. The next part, they ask calculate the total upward force. So to calculate the total upward force, we'll calculate the force exerted by one piston and multiplied by 4. That will be the total upward force. So this piston, the pressure will be 100,000 Pascal and the area of each piston is 0.02.
Multiply.
So 100,000 multiplied by 0.02, it means we have 2000 Newton. So 2000 Newton is the force applied by one piston. So and each piston having a same area. So each piston apply the equal 2000 Newton upward. So what will be the total upward force? So 2000 multiplied by 4, that's equal to 8000 Newtons. So the total upward force is equals to 8000 Newton. The next part, the weight of each of the two car support is 1000. Calculate the mass of the car. So first you have to make the figure. In this figure, the upward force by each piston is 2000. And weight of the car is acting down, and weight of the car supports are also acting down. So weight of the car we don't know, we say W. Mass of each car support is 1000. So this is 1000. This one is also 1000. Because they mentioned in the question, the weight of each car support is 1000. So what is the total upward force and what is the total downward force?
Total upward force is 6,000.
The total upward force is 8000 because 2000, 2000. So total upward force is 8000. The total downward force is the weight of the car plus 2000.
2,000, yes.
Because the weight of the car supports. So 2000 is added, other side it will be subtracted. So 8000 minus 2000. So weight of the car is equals to 6000 Newton. But in the question, they asked for mass.
Divide by 10.
So divided by 10 to get the mass of the car, so that you will get 600 kg. So mass of this car is 600 kilogram. Is it clear, this question?
Yes, sir.
So in the last part, they ask calculate the mass of the car. So if we need a mass of a car, so first we get the weight of the car support, the weight of the car support downward, weight of the car is also downward. And we already know the upward force was 800. So if all are balanced with each other, the 800 Newton upward, 1000 Newton down, 1000, and weight of the car also acting down. So upward force equal to downward force. So upward force is equal to 8000 and the downward force is equals to 1000 plus 1000 plus weight of the car. And when you solve 1000 plus 1000, that's 2000, and 8000 minus 2000, that's equal to 6000. So weight of the car is 6000, but we need a mass of the car. So we have the formula weight is equals to mass multiplied by gravity, or mass is equals to weight divided by gravity. Weight of the car is 6000 and the gravity is 10. So the mass of the car will be 600 kilograms or kg. Is it clear, this example? This was a weekly homework exercise momentum. Any doubt in this exercise of momentum? Mention a question in which you have doubt. Exercise momentum. Question 2 part B. So in question number 2, a figure 2.1 shows two railway trucks. The truck A has a mass of 6000 kilogram and it is moving at 5 meter per second. And it approaches a truck B of mass 5000 kilogram, which was stationary. Calculate the momentum of truck A. The momentum is a product of mass and velocity. So mass of a truck was 6000 multiplied by speed or velocity, it was 5. So 6,000 multiplied by 5. So it will be 30,000 Newton second or kilogram meter per second. The truck collide and their buffer compresses. They bounce off each other, remain undamaged. After the collision, the truck B has a momentum of 27,000. Determine the impulse. Impulse means the change in the momentum. So what, the original momentum was 0 because it was stationary. And impulse means the change in momentum. So final momentum is 27,000. So if you determine the impulse, so 27,000 minus 0, which is also equal to 27,000 Newton second or kilogram meter per second. You can mention both. In the third one, B2, the trucks are in contact for 0.6 of a second. So if they're in contact for a 0.6 of a second, you have the impulse, which was 27,000 Newton second. You need a force. Force is equals to impulse multiplied. Impulse is equals to force multiplied by time. So force, you need a force. So force is impulse divided by time. So impulse, you already have 27,000 divided by 0.6. You will get the resultant force. And the last part, calculate the speed, the final speed of truck A. So how to calculate the final speed of truck A? When two objects are colliding, the momentum before collision is equals to momentum after. The total momentum before collision for two objects before collision is equals to total momentum after collision. So if I show the figure here, the momentum before collision, as we work out the momentum before collision for truck A was so in the beginning or the start, the truck A was having a momentum of 30,000. The momentum of truck B was 0 because it is stationary. Momentum after collision, the momentum of truck B was given 27,000. So what will be the momentum of A after collision? So when you subtract 30,000 minus 27,000, you will get 3,000. So the momentum after collision for A is 3,000, but we need a speed. And what is the formula for momentum? Momentum is mass into velocity. So we can say 3,000 is equals to mass of a truck, which is 6,000, multiplied by its velocity. Velocity we don't know, so we say V. So 6,000 is multiplied, other side it will divide. So 3,000 divided by 6,000. So you will get 0.5 meter per second. Is it clear? In MCQs too, a bullet of mass 0.1 traveling horizontally at a speed of 600. It strikes a stationary wooden object of mass 1.5. The bullets stay in the block, so means both will move together. What is the speed of the bullet and a block after the collision? So whenever two objects collide, the momentum before and momentum after should be same. So what is the momentum before for a bullet? The mass of the bullet is 0.1 multiplied by speed at which it was moving is 600. The wooden object was stationary, so its momentum is 0, equal to momentum after collision. The mass of the bullet remains same, 0.1, and speed at which the bullet is moving is unknown v, plus the mass of the block is 1.9, and the speed at which the block is moving is also v. Why? Because both stick together or stay together. It means both are moving with the same speed. So 0.1 multiplied by 600, so it will be 60. This is 0.1 v plus 1.9 v. That's so 60 is equals to 2v. So if 2 is multiplied, other side it will be divided, so it will be 30 meter per second. The momentum for two objects before collision is equals to momentum after the collision. That's a conservation of momentum. In question 4, a moving ball has a momentum of 25. So its momentum is 25. It collide, it bounce back with the same speed. So if speed does not change, it means the magnitude of the momentum will not change, but the direction changes. It's in opposite direction. So if one momentum is positive, the other one should be negative. So if one is positive, the other one should be negative. The time for the collision is 50 milliseconds. You need an average force. To get a force, first you find impulse. Impulse is change in momentum. So final momentum is minus 25 minus the initial momentum is 25. So the impulse is equals to minus 50. Because the impulse is the change in the momentum. So final momentum is minus 25. Initial momentum is plus 25. So change in momentum is minus 25 minus 25. That's equal to minus 50. But you need a force. Force is impulse divided by time. So force was minus 50. And the time interval, what's the time interval given? It's 50 millisecond. 50 millisecond means 50 into 10 to the power minus 3. So what's the final answer? 50 divided by, so 1 exponent minus 3, so it will be 1000 Newton. Is it clear? A moving ball with a momentum of 25. So this ball is having a momentum of 25. When it hit, it bounced back with the same speed. So if the speed does not change, the value of the momentum will not change. But it in opposite direction. Momentum is a vector quantity. So if one momentum is positive, the other one should be negative. And so you need a force. To get the force, first you need an impulse. Impulse is equals to final momentum minus initial momentum. So the final momentum is minus 25 and the initial momentum is 25. So minus 25 and minus 25, you will get minus 50 Newton second as an impulse. But in the question, you need a force. So force is impulse divided by time. Impulse is given minus 50 and the time is 50 millisecond, means 15 to 10 to the power minus 3. So when you solve this, you will get the answer as 1000 Newton. Is it clear? Any other question in this exercise?
Sir, on paper for the structure questions, 1A, question number, part 2.
Question number?
1A, structure questions.
Okay, 1A. This one, the dummy.
Yeah.
Figure 2.1 shows a dummy of mass 70 kilogram. So mass of this dummy is 70 kilogram. Used in a crash test to investigate the safety of a new car. The car approaches a solid barrier with 20 meters per second. Look, example, if you are in the car, your car is moving with 20 meters per second. What is your speed? Your speed is also 20 meters per second because you are in the system. So speed of the car is same as the speed of the dummy. That's why the dummy will remain inside the car. If dummy was moving slower, the dummy should be outside the car. If dummy is moving faster, then dummy should be ahead of the car. But both are moving with the same speed. That's why dummy is inside the car. So the car approaches a solid barrier at a speed of 20 meters per second. It crashes into a barrier and stops suddenly. So with the moment the car stops, calculate the moment of a dummy immediately before the crash. So immediately before the crash, as the speed of the dummy is 20 and the mass of a dummy is 70. So what was a momentum before the crash? So momentum is a product of mass and velocity. So 70 multiplied by 20, which is equals to 1400 kilogram meter per second. And in the next part, determine the impulse. Impulse means change in momentum. So there are two formulas for impulse. It's either force multiplied by time or the change in the momentum. So as we know, impulse is equals to final momentum minus initial momentum. The final momentum of the dummy, because the dummy stop also as a car, as a dummy we bring it to rest, so the finally it will be 0. And what was the initial momentum? We already calculated. That's 1400 or 1400. So impulse will also be negative 1400 Newton second or kilogram meter per second. Is it clear?
Yes, sir. No, so my question is, I saw the mark scheme.
1400.
Yeah. So is it okay?
It is right. It is right because actually, what happened? The negative in a vector quantity, the significance of a negative sign is the direction. So if the question was like in what direction, what is the direction of the impulse compared to original motion? In that case, the sign shows a significance. Otherwise, the magnitude is important. Here, the marks are for the magnitude, not for the sign. That's why it is of only 1 mark.
Okay, sir. Thank you.
In question 10, B2, B1 and B2 are related to each other. In a game of a tennis, a player hits a stationary ball with his racket. The racket is in contact for 6 milliseconds. So 6 milliseconds means 6 into 10 to the power minus 3 seconds. The average force on the ball is 400 Newton. What is the impulse? So impulse having a two formula. Impulse is change in momentum or force multiplied by time. So here you have the force 400 and you have the time which is 6 millisecond or 6 exponent minus 3. So when you solve, you will get 24 Newton second as an impulse. The mass of the ball is 0.05. Calculate the speed which the ball leaves the racket. Originally, you can see a player hits a stationary ball. Now you will use the same formula, second formula for impulse. Impulse is change in momentum, which is mv minus mu. And the ball was stationary, so initially it will be 0. Impulse is 24. Mass of the ball is 0.056. Speed of the ball you don't know. And this whole, because initial is 0, so this whole factor will be 0. So 24 divided by 0.056, you will get the speed at which the ball will leave the racket. Is it clear?
Sir,
Yes.
isn't the first one 2.4?
4,000. Okay, yeah, that's 4,000. Sorry, I read as 400. That's 2.4. That's correct. Because this is, I wrote 4,000 here, this is 400. If it was 4,000, then it is 24, but it is 400, because of that, it's 2.4.
Okay.
Why it is 6 exponent? Because it is written 6 milli. So the term milli means 10 power minus 3. If you check this, this is a prefix use which shows millisecond. The term milli means, in the first lecture I explained, this is having significance. It shows it is 10 power minus 3. Any other doubt? Question 3C. This is question 3C. A modern car is designed so that during a collision, the front section of a car is crushed and time of a contact increase. Explain the benefit of increasing the time of a contact for a people in the car. Because what happened, you can see the relation between force and time. Impulse is force multiplied by time. So relation between force and time during a collision, they are inversely proportional. So if these cars are designed, when there's a crash or accident, the design of the car, or these are called a crumple zone. So they will take more time, or they will take energy or absorb energy as they crumple or they deform. So as the body of the car deform, it will increase the time for the object to stop. So as it will increase the time for object to stop, the force which the car will experience will decrease. As the force experienced by the car will decrease, the driver will also experience less or a smaller amount of force, which reduce the chance of injury or a fatal injury. So these crumple zones absorb energy, increases the time for the object to stop, which reduce the force acting on the car and make it safe or reduce the chance of injury. Is it clear? Otherwise, within an instant, if the car stops, it will experience, the passenger will experience the maximum force, and that can be fatal. The same thing, 1D. What is the benefit for the safety? The same answer is there. That what happened, how the seat belts and airbags make it safe for the passenger. because these seat belts, the seat belt and the airbag here, it increases the time for object to stop. So if the time increases, the object will experience less force, so less likely it will cause an injury. If anyone else also having a doubt, can send on WhatsApp. I will answer his doubts. Other than these questions, I will end the session and share the recording with you.